Let's explore one of the most important and fast-changing parts of the chemicals and materials world, the energy, mobility, and environmental solutions block. Think of this block as the set of chemistries, additives, and materials that help vehicles run better, reduce emissions, keep buildings cool, protect people from fire, and support the global shift toward cleaner energy. These products sit right between the raw chemicals upstream and the final applications we use in everyday life, things like cars, aircraft, HVAC systems, and environmental projects. They play a crucial role in helping industries meet safety rules, environmental standards, and energy transition goals. Inside this block, there are 5 major groups of businesses. The first is battery and energy storage chemistries. These companies make cathode and anode materials, electrolytes, separators, binders, and specialty additives that help electric vehicles and grid batteries store energy safely and efficiently. They also make thermal management fluids to prevent batteries from overheating. The second group is tire and mobility performance additives. These are the chemistries that help a tire grip the road, roll smoothly, wear more slowly, and improve the efficiency of both petrol and electric vehicles. The third group is fuel additives and emissions control chemistries. These additives improve how fuels burn, reduce NOx, stabilize fuel quality, and support emissions after treatment systems. The fourth group includes refrigerant and fire safety materials. These products are essential in HVAC systems, heat pumps, refrigeration, fire suppression systems, and insulation foams. And the fifth group is RNG, SAF, and environmental absorbent solutions. These provide inputs for renewable natural gas and sustainable aviation fuel. They also include absorbents used in environmental cleanup and decarbonization projects. Across all 5 groups, companies sell 4 main categories of offerings: high-purity chemistries and additives like catalysts and surfactants, materials such as refrigerants or fire safety agents, technical services around performance testing and compliance, and long-term supply arrangements with major manufacturers in automotive, industrials, aerospace, and other regulated industries. Their customers range widely, from automotive OEMs and tire manufacturers to refiners, airlines, HVAC equipment makers, utilities, and government bodies that oversee safety and emissions. This block sits in the midstream to downstream part of the value chain. It relies on upstream basic chemicals, and its products flow into vehicles, fuel systems, industrial equipment, compressors, HVAC units, and environmental processes. It also links closely to other parts of the chemicals ecosystem. It depends on industrial chemicals and materials for its feedstocks. It supplies high-performance inputs to polymers and advanced materials and CASE, and it ultimately enables large downstream sectors such as automotive, aviation, energy, HVAC, and environmental services. To make this clearer, here are 10 illustrative companies in this block. Again, purely as examples, not as stock recommendations. Chemours in the US supplies refrigerants and fire safety chemicals. Arkema in France makes high-performance materials for batteries, coatings, and mobility additives. Honeywell provides refrigerants, fire safety materials, and energy-efficient chemistries. 3M creates mobility additives, advanced materials, and filtration chemistries. BASF in Germany makes battery materials, emissions catalysts, and additives. Evonik provides specialty additives for tires, fuels, and environmental systems. Johnson Matthey in the UK develops emissions control catalysts and hydrogen-related chemistries. Umicore makes cathode materials and supports battery recycling. Linde supplies industrial gases critical for battery and mobility manufacturing, and Solvay provides high-performance chemistries for mobility, thermal management, and electrification. There are also emerging challengers. Ascend Elements in the US uses closed-loop battery recycling to create cathode precursors at lower carbon intensity. And Novanix focuses on next-generation anode materials and fast cycle testing, pushing innovation in the energy storage supply chain. Companies in this block operate under different models. Some manufacture high-spec chemicals, which requires heavy capital for large plants, while others focus on formulations and specialty additives, which are more asset-light but R&D intensive. Many also build long-term technical supply relationships, where switching is difficult and slow, especially in automotive and aviation, and some provide chemistry-linked services like compliance or material qualification. Capital is tied up in plants, labs, inventories, and long approval cycles. The economics are shaped by specialization in switching costs, regulation, scale, and integration, and the ability to price when performance or compliance matters. Profitability varies by segment. Specialty additives typically earn around 20 to 25% margins, refrigerants 15 to 30%, battery materials 10 to 25%, and environmental absorbents about 10 to 15%. 5 key drivers shape this entire block. First and most important is regulation and compliance, which affects refrigerants, emissions controls, and fire safety materials. Second is the electrification and mobility shift, with EV battery capacity expected to exceed 5 to 6 terawatt-hours globally by 2030, which directly increases demand for battery-related chemistries. Third is vehicle park growth. The global vehicle park is now over 1.4 billion vehicles, and tires need replacing every 3 to 4 years, supporting steady demand for tire additives. Fourth is energy transition policies, including SAF mandates and phase-downs of high GWP refrigerants. And fifth is feedstock and energy costs, because many of these chemistries depend on fluorine derivatives, specialty solvents, and gas-based energy. This block behaves in a mixed way across the business cycle. Automotive OEM demand is cyclical, so recessions slow demand for battery and mobility additives. But many other parts of this block are more defensive. Tire replacements follow the installed base of vehicles. Refrigerants, fire safety chemicals, and environmental solutions are linked to maintenance rather than discretionary spending. The block responds clearly to changes in economic conditions. If interest rates rise, auto sales slow, and battery and mobility additive demand softens. If fuel prices rise, demand increases for additives that improve combustion efficiency. If regulation tightens, refrigerants and emissions materials gain pricing power. If industrial production weakens, volumes for mobility additives tend to moderate. On the behavioral side, some products are true must-haves, like tire replacements, refrigerants, and emissions control materials. Upgrades, such as premium EV additives, are more discretionary. And when budgets tighten, companies may postpone some maintenance purchases for a few months, but they rarely cut them entirely. A lot has shifted recently. The largest change is the pressure from electrification. EV penetration rose from about 4% in 2020 to around 18 to 20% in 2024, and this pushed materials demand away from combustion engine additives and toward battery-grade chemistries. Second, refrigerant regulation accelerated. Under the Kigali Amendment, countries have phased down high GWP HFCs, giving rise to low GWP refrigerants such as HFOs. Third, sustainable aviation fuel, or SAF, has emerged as a real market. SAF demand was almost zero in 2020, but with mandates in the US and EU, it is now reaching early commercial scale. Fourth, the cost structure of the industry shifted after energy prices rose sharply in Europe during 2021 and 2022. This improved the competitiveness of plants in the US and Middle East. And fifth, bargaining power inside the value chain changed. Battery material suppliers gained pricing power because OEMs needed reliable partners. Legacy refrigerant suppliers weakened as reclaim markets and alternatives expanded, and tire additive suppliers faced margin pressure because feedstock prices rose. Looking ahead, this block sits at the center of energy transition, mobility change, and tightening regulation. Near term, 1 to 2 years, many fundamentals stay the same. Regulation continues to shape refrigerants and emissions materials, tire replacement demand stays steady, and OEM qualification cycles remain slow and sticky. What fades is high GWP refrigerants and some fuel-dependent additives as EVs rise. Growth moves into EV battery additives, thermal fluids, early SAF production, and heat pump refrigerants. Medium term, 3 to 5 years, relationships with OEMs and regulators still support pricing power, and tire and mobility additives follow vehicle park growth. But combustion engine chemistries decline, and commodity refrigerants weaken. Growth shifts clearly toward EV-specific materials, scaling SAF blends, heat pump refrigerants, and circular battery recycling. Long-term, 7 to 10 years, sticky performance materials remain strong, but ICE-linked additives shrink and legacy fluorochemicals face tougher rules. Growth comes from advanced and safer battery chemistries, hydrogen mobility, fire safety materials, environmental absorbance, and decarbonization inputs like SAF and carbon capture. Scenarios. In the upside, rapid EV and heat pump adoption plus supportive regulation drive strong growth and margins. In the base case, growth is steady and mid-single digit. In the downside, slower transition, overcapacity, and rising costs compress margins and growth.